welcome to Fascinating Frontiers, episode 110, coming to you on June 23rd, 2026. Here's what's happening in space and science today. An interstellar comet that passed the sun last year may be nearly 3 times older than our solar system and formed in a stellar system nothing like our own. Spectral data from the object point to formation 10 to 12 billion years ago inside a cold, dense cloud belonging to a now ejected stellar system. Its ices and dust differ sharply from any material found in our own solar system. Astronomers plan to use follow-up observations to test models of how planetesimals scatter between stars. Now shifting to a reanalysis that questions one of cosmology's central assumptions. Researchers at the Tata Institute of Fundamental Research and the University of Oxford examined the Pantheon Plus supernova catalog and found no compelling evidence for accelerating cosmic expansion. The team argues that earlier conclusions depended on assumptions about supernova standardization that may not hold across all redshifts. Their letter and monthly notices of the Royal Astronomical Society suggest the apparent acceleration could result from calibration effects instead of dark energy. The finding sits squarely inside the ongoing Hubble tension debate. Additional independent datasets will be required to test the revised interpretation. On a different note, a globular cluster is offering clues about the Milky Way's earliest assembly phase. Astronomers studying Tarzan 5 have identified chemical and dynamical signatures indicating the cluster formed before the galactic disk fully settled. The cluster contains stars spanning a wider range of ages and metallicities than typical globular clusters. Its orbit and internal structure align with formation during the galaxy's original mergers. Researchers are now comparing Tarzan 5 against simulations of those early galactic mergers. Further spectroscopic surveys will check whether other clusters share the same history. Next up, a new forecasting approach aims to predict when New Horizons reaches the heliosphere's edge. Southwest Research Institute scientists are combining solar wind predictions with analytic models to locate the first plasma boundary the spacecraft will encounter. The method integrates data from multiple inner solar system monitors to improve timing accuracy. Scientists will compare the model outputs directly against New Horizons measurements once the boundary is crossed. Turning to infrastructure protection, a dedicated tracking network for cosmic threats has received major recognition. A proposal to build a dedicated network for tracking cosmic threats to satellites and future off-world bases has won the 2026 Schweikart Prize. The concept emphasizes rapid detection and characterization rather than deflection alone. Organizers noted that the plan fills a gap between planetary defense and operational space systems. Next steps focus on sensor placement and data sharing protocols with commercial operators. Meanwhile, a 50-year-old dataset continues to spark discussion about life on Mars. Threads are revisiting the 1976 Viking lander biology experiments that tested for metabolic activity in Martian soil. The original labeled release results remain ambiguous between biological and chemical explanations. Recent comparisons involve modern instruments such as Perseverance's Sherlock and Pixel. Contributors note that sample handling differences between 1976 and today limit direct comparisons. The conversation centers on what a new dedicated life detection mission would require to settle the question. Shifting focus inward, magnetic fields inside molecular clouds are being mapped as a structural skeleton that guides star formation. New observations have traced magnetic field lines, threading a molecular cloud and channeling gas towards sites of star formation. The fields act like scaffolding that both supports the cloud against collapse and directs material along preferred directions. Regions showing stronger alignment between field and density gradients form stars more efficiently. The study combines dust polarization measurements with velocity information from molecular lines. Researchers plan to apply the same technique to additional clouds to test how universal the pattern is. A typical star-forming molecular cloud can stretch 50 light-years across, yet contain magnetic fields strong enough to influence gas motions on scales of only a few hundred astronomical units. Gas parcels traveling through these fields are guided along the lines rather than falling straight inward under gravity alone. In regions where the field runs parallel to dense filaments, collapse proceeds rapidly, while perpendicular orientations can slow or redirect the flow. Temperatures hover near 15 Kelvin, and the fields themselves carry energy densities comparable to the turbulent motions inside the cloud. Despite these maps, astronomers still cannot explain why some clouds with nearly identical field strengths convert gas into stars at very different rates. The missing piece may lie in how the fields connect to larger galactic structures, or in small-scale reconnection events that suddenly release material. Elsewhere, flickering from a distant quasar is revealing unexpected disk structure in the early universe. Astronomers have detected flickering from quasar J0439 plus 1634, seen as it appeared only 850 million years after the Big Bang. The variability pattern indicates a flat pancake-shaped accretion disk around the central black hole, similar to those observed in nearby quasars. This finding challenges models that predicted thicker or differently structured disks in the early universe. Additional monitoring campaigns are underway to map the disk's properties in greater detail. On the dark matter front, theorists are examining whether asteroid-mass primordial black holes could account for the universe's missing mass. These objects would have formed in the first moments after the Big Bang and would interact only through gravity. Gamma-ray observations of the cosmic background are being re-examined for subtle signatures that might reveal such a population. Current limits still allow a fraction of dark matter to exist in this form. Next-generation telescopes could tighten or confirm the possibility. Moving to launch activity, Rocket Lab has supported a U.S. Space Force responsive space exercise. An Electron mission placed a spacecraft into orbit to support the Victus-Haze demonstration. The satellite will work with a true anomaly vehicle to practice rapid threat identification and rendezvous operations. The launch continues Rocket Lab's role in national security missions requiring short notice deployment. Ground teams are now commissioning the payload and beginning the exercise timeline. Data from the mission will inform future responsive launch concepts. At Kennedy Space Center, a new report assesses whether current facilities can handle the coming heavy lift era. The analysis identifies needs for upgraded roads, propellant handling, and payload processing buildings. Current infrastructure was designed around vehicles smaller than the next generation of super heavy boosters. Recommendations include phased upgrades rather than wholesale replacement. NASA and commercial operators are reviewing the findings for budget planning. A new White House directive instructs NASA to develop plans for quantum-enabled navigation, sensing, and secure communications in space. The order aims to coordinate federal efforts on quantum technologies that could improve precision timing and encryption for deep space missions. NASA is expected to outline specific technology roadmaps within the coming months. The initiative includes both near-term demonstrations and longer-term infrastructure concepts. Industry partners have already begun aligning proposals with the stated priorities. Looking ahead to tomorrow, a suborbital rocket from Wallops will carry student-built experiments. The flight window opens at 5:30 a.m. Eastern Daylight Time on June 24, with a backup day the following morning. Student payloads under the ROCSAT-X and ROC-ON programs will measure atmospheric properties and test small hardware systems above most of the atmosphere. The programs give participants direct experience with payload integration and launch operations. Results will be shared after recovery and data analysis. Finally, a newly characterized exoplanet is displaying extreme atmospheric behavior driven by its orbit. The world follows a highly eccentric path that brings it dramatically close to its star on each orbit. The extreme heating and cooling cycle produces atmospheric dynamics not seen in more circular orbits. Observations are revealing how the planet's temperature swings affect cloud formation and heat redistribution. The system offers a natural laboratory for testing atmospheric models under intense stellar forcing. Continued monitoring will track whether the orbit is stable or evolving. Persistent heavy rains have expanded Lake Naivasha in Kenya's Rift Valley. flooding farmland that supplies much of Europe's cut flower market. Satellite imagery shows the lake has grown significantly over recent seasons, displacing greenhouses and infrastructure. The changes also affect local water quality and wildlife habitats around the lake. Earth observing missions continue to track shoreline movement and sediment patterns. Local authorities are evaluating adaptation measures based on the ongoing data. New observations keep rewriting what we thought we knew about how stars and galaxies came together. Keep an eye on the sounding rocket launch window opening tomorrow morning at Wallops for the latest student payload results. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give OmniView a listen, a balanced daily world-news briefing that takes every side seriously. You can explore the whole lineup at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly